Let's look at the Pythagorean identity sine squared plus cosine squared equal to 1. I want to know why this is true. For any given angle and standard position, I can define a reference triangle by drawing a perpendicular line from the terminal side to the x-axis. And then I refer to my reference angle right here, which will be my theta. In this case, we have our x is going to be our adjacent side, y is going to be the opposite side. We do know that x squared plus y squared is equal to r squared, where r is this other side, by the Pythagorean theorem. And if I divide everything by r squared, I would have x squared over r squared plus y squared over r squared is equal to r squared over r squared. So this is x over r squared plus y over r squared is equal to 1. X over r is adjacent over hypotenuse, so this is cosine. Y over r is opposite over hypotenuse, so this is sine. So this tells me that cosine squared plus sine squared is equal to 1. Now that I have this trig identity, I can use this to find the other two Pythagorean identities. Let's start by dividing everything by sine squared. So I have sine squared theta over sine squared theta, cosine squared theta over sine squared theta, and 1 over sine squared theta. This is a 1. Cosine over sine is cotangent, so this is cotangent squared theta. And 1 over sine squared is cosecant squared. So I have another Pythagorean identity of 1 plus cotangent squared theta is equal to cosecant squared theta. To get my third Pythagorean identity, I'm going to divide everything by cosine squared. So we have sine squared over cosine squared theta, cosine squared theta over cosine squared theta, and 1 over cosine squared theta. Sine over cosine is tangent, so this is tangent squared theta. Cosine squared theta over cosine squared theta is 1, and 1 over cosine squared theta is secant theta. So this is secant squared theta. So tangent squared theta plus 1 is equal to secant squared theta.